Hello, my friends, and welcome to this educational series in your favorite subject, chemistry. Today, my friends, we are going to answer the questions we have taken as homework in the previous class, and we are going to learn a new piece of information, which is how to name the chemical compounds after we have known how to write a chemical formula of a chemical compound. Now, my friends, here the first question is make chemical compounds using the following ions. So here I have copper 1, I have sulfate, lead 4, carbonate, aluminum, dichromate. I have also ammonium and phosphate. And here, my friends, allow me to remind you of the three important rules we have taken in this field. First, my friends, we said that always we should keep the positive ions or the cations left and the negative ions right. So far everything is fine and everything is correct. Rule number 2, my friends, as you know, we said that if the two charges or the two numbers are the same, we join them into one formula without looking at the numbers or charges. Here we don't have any similar charges. And the situation number 2, if they are different, I should multi or cross multiply them here. Like copper, I multiply it with 2, Cu, this is Cu. SO4, I multiply it with 1. I have lead, multiply it with 2. And here I have this polyatomic ion, and as we said before, my friends, if the polyatomic ion is multiplied with 1, I write it as it is, but if it's multiplied with a number which is over than 1, I should here draw parentheses and draw the number here, and then at the end I should write it inside those parentheses. Again, we have aluminum plus 3, which should be multiplied with 2, and dichromate, which is a polyatomic ion, and it's multiplied with a 3, which means I should draw here 2 parentheses in order to protect it and to deal with it as one atom. I write the number outside, and then Cr2O7, aluminum, dichromate. Then, my friends, I write here, this is NH4, should be into parentheses 3, and PO4, my friend, which is a polyatomic ion, doesn't need a parentheses because it's multiplied with 1. Now, parentheses because it's multiplied with 1. Now, here, my friends, correct the wrong formula. Here we go quite the opposite. I write first the ions I have. This is ammonium. Ammonium is plus 1, yes. And I have sulfate. Sulfate is, yes, minus 2. Here I have Na sodium, plus 1. I have oxygen, or oxide now in our case. It's oxide because it is an ion now, minus 2. There is oxide. I have F, which is fluoride, minus 1. And Br, bromine, also minus 1. I have here aluminum, which is plus 3. And CH3COO, which is minus 1. I also ignore all the numbers because I need to take only the ion in isolation. So let's apply the 3 rules we have learned. Always, my friends, the left ion should be the cation, and the right one, it should be the anion. This is correct here in this term. This always applied. This one is wrong because I have 2 negative ions, and 2 negative ions cannot be joined together in one chemical compound. Here, my friends, a lot of students told me, teacher, this is correct. cation or the positive ion is left and the negative ion is right, I tell them this is correct when we talk about any other anions, because generally, my friends, you all know that the acetate and the formate are the only exceptions, and for them, the negative ion should be left and the positive ion should be right. Here, aluminum plus 3, this is correct now. Then, my friends, I join them together, and as I told you before, if the two ions have the same charge, I join them without numbers or charges, and if they are different, I should cross multiply them. Here I have NH4, I multiply it with 2. Teacher, why did you draw parentheses? Because this is a polyatomic ion, and this polyatomic ion is multiplied with a number which is higher than 1. Here SO4 is multiplied with 1, so no need for parentheses. Here we have Na2. Oh, teacher, why don't you write Na parentheses 2O? Because I use parentheses only with the polyatomic ions, not with the monoatomic ions. And here, my friends, I gain here CH3COO parentheses. I should multiply them with 3, and aluminum is multiplied with 1. That's it, my friends. This is our homework. And now, my friends, let's start learning how to name a chemical compound. Generally, my friends, as you have seen so far, a chemical compound or a chemical formula here has two parts. The first one is the positive ion, and the second one is the negative ion. Let's start with the positive ions. Here, my friends, in the positive ions, we say that the positive ions have always the same names as their atoms. For example, this is a sodium atom, and this is a sodium ion. This is a calcium ion, and this is a calcium, let's say, atom. So if the atom loses one or more electrons, it becomes a positive ion or a cation, but its name doesn't change at all, like magnesium, sodium, calcium. In here, I have only one exception, which is ammonium. So please, my friends, try to memorize it. Now, my friends, we have for ions with more than one option of charge. As you all know, some atoms or some ions are confusing. They could take 2 or more charges. Like copper, we have copper 1 and copper 2. As we said before, we use the Roman numbers. This is number 1, number 2, number 3, 4, 5, 6, 7, and that's it. Here we have copper 1 because it lost 1 electron. Here we have copper 2, we have iron 2, iron 3, lead 2, and lead 4. That's it, my friends. Again, in short, for the positive ions inside the chemical compound, they have the same name of their original atoms. We don't change their names. We don't add any prefixes or suffixes to the name. And we have an exception, which is ammonium here. And as we know, if the atom can lose 1 or more electrons, we have more than one option here. We have to use the Roman numbers next to the name of the cation. Now, my friends, what about the negative ions or the anions? Here, my friends, we have two options. The first one is if the negative ion is with any other cation except for hydrogen plus. In here, my friends, we have also two options. The negative ion could be monoatomic or polyatomic, and I'm going to start with the monoatomic here. If a monoatomic anion is with any positive ion or with any cation except for H+, we add the suffix "ide" to the name of the atom. Here, my friends, for example, we have calcium. You know, the positive ion doesn't change. Calcium chloride, IE. Here, I add the suffix "ide." Here, I have sodium. Again, my friends, the positive ions, when they are related to negative ions, they don't have any changes in their names, while a monoatomic ion, which is related to any cation except for H+, is going to be added to the suffix "ide." So I have calcium chloride, sodium oxide. Here we have iron 3 sulfide, and here the exception, it's not a monoatomic, but also it takes the same suffix. Again, my friends, generally, if the negative ion is monoatomic, its name will be changed when it becomes a negative ion. We add the suffix "ide" to its name. So Chlorine will be chloride, oxygen will be oxide, sulfur will be sulfide, and we have the exception here, cyanide. So what about the other option? Here, if the anion is polyatomic and it is related with any cation except for H+, we add the suffix A to its name. For example, here we have copper 2, ammonium, barium, aluminum. You see those are positive ions or cations. Their names are still the same. I only add 2 here because I have 2 types of copper, copper 1 or copper 2. This is copper 2 because if you go back to it and you dislocated it, you're going to see that here we're multi or cross multiplied. So this is 3 for the phosphate and this is 2 for the copper. Here we add phosphate. So this is copper 2 phosphate. This is ammonium sulfate, and this is here barium nitrate. And again, my friend, here we have aluminum chromate. Again, my friends, quickly, what have we learned so far? We have learned so far how to name the chemical formula. We started by saying that any chemical formula has 2 parts, the positive ion and the negative ions. We started naming the positive ions, and we said that the positive ion, especially if it's monoatomic, has no changes in its name. So the name of the atom is going to be the same as the name of the cation. And we had an exception here, which is a polyatomic ammonium. And number 2, we said if the cation has, or if the cation can have more than one option for its charge, we add the Roman numbers next to its name so that we can differentiate between those 2 options. And then, while for the negative ions, my friends, we said that the name of the atom is different from its anion. For example, we said if a negative ion is with any cation except for hydrogen, of course, we have monoatomic ions. We add the suffix "ide" for the names. For example, as you know, this is a chlorine because it is neutral, but when it becomes negative ion, it's going to be chloride. This is oxygen when it is neutral, when it is related to a positive ion, and when it is a negative ion, it's become oxide. We have sulfide and we have cyanide as an exception. Again, my friends, for the polyatomic ions, we add the suffix "ate" to their names. For example, this is phosphorus generally, but when it becomes in a negative ion with polyatomic, it becomes phosphate. We have thiosulfate, we have nitrogen, it becomes nitrate, and we have chromate. Now, my friends, let's go and learn how to name a negative ion which is related or which is attached to the cation H+. Well, in here, my friends, we have also 2 options. The first one, if the negative ion or the anion is with H+, and it is, number 1, monoatomic, you have those fluoride, chloride, bromide. Here we add this formula. We have hydro, this is a fluor, this, for example, this is hydrofluoric acid. For a bromine, hydrobromic acid. For a chloride, hydrochloric acid. So here we have hydroic acid, and we add the name without, of course, the suffix before. So it's going to be hydrofluoric acid, hydrobromic acid, and hydrochloric acid. For H2S, we call it dihydrogen sulfide. For this one, here we have hydrogen cyanide. And of course, a lot of students ask me, teacher, what about the oxide? When oxygen or oxide is related or attached to H+, 1 oxide minus 2, multiply them here, we have H2O, which is water. Now, the other option is when the negative ion or the anion is with H+, with the hydrogen ion, and it is polyatomic. In here, my friends, I think it's easier. We only need to add the suffix ic acid. For example, here we have nitrate, as you see here is the nitrate. Yes, the nitrate. We delete the 8, we leave nitrate. niter, then we add ic acid, so we have nitric acid, ic acid. Teacher, why did you change it? Because generally, my friend, as I told you before, we add 8 when the negative polyatomic ion is attached to any cation except for hydrogen. Here it is attached to hydrogen, and we should change the suffix. So I take the suffix here off, I deleted it, and I add ic acid. So we have here nitric acid. Why it's nitric acid? Why the ic acid? Because it is attached now to hydrogen or hydrogen ion. So this is sulfate in the past. Now it became sulfuric acid because it's an acid now. Here we have carbonate. In the past it was carbonate. I delete this 8 because now it is attached to hydrogen ion. We say carbonic acid, and we have here acetate. Acetate will become acetic acid, here formate, formic acid, and here phosphoric acid. Again, my friends, let me summarize what we have learned so far. In here, my friends, we said that a negative ion changed its name when it is related to positive ions, to the positive ions which have the same name when they were atoms, and when they become ions. In here, the negative ion, if the negative ion is related or is attached to hydrogen here, and it is monoatomic or polyatomic, all of them we call them acids. So if any negative ion is attached to the H plus cation, we call it acid, whether it is monoatomic or polyatomic. The difference here is in the suffix used for naming. If it's monoatomic ion, like fluorine, bromine, here chlorine, we add hydroic acid. For example, we have here hydrofluoric acid, hydrobromic acid, and hydrochloric acid. This rule doesn't apply for the other monoatomic anions. We have here dihydrogen sulfide, we have hydrogen cyanide, and for oxide it becomes water because hydrogen with, as you know, oxide becomes water. Generally, polyatomic ions or polyatomic anions, when they are attached to hydrogen, also they are acids, but the name is different. Here we add ic acid, and we delete the 8 because we add 8 when the polyatomic anion is attached to any other positive ion. All of those positive ions make them 8 for the polyatomic 8. As you see here, here you have bicarbonate, nitrate, formate, acetate. When they are what? Attached to any positive ion of those except for hydrogen, but when they are attached to hydrogen, they becomes acids, and the acids have their own, let's say, suffixes. In here, nitric acid, sulfuric acid, carbonic acid, acetic acid, formic acid, and phosphoric acid. Thank you, my friends. That's it for today. I know this class was a little bit tiring, a little bit arduous, but believe in me, if you replay this video again and play some Kahoot games which are related to this topic, you are going to get better understanding. Thank you, my friends, again. I hope you enjoyed this class, and see you in the next classes.